Welcome back. We're on to the next lab, but before we move on to that, I just wanted to go back and address the problem where I couldn't do a layer 2 ping to Fabric I&C. So I noticed that there wasn't a host name configured against the prompt, so it said the prompt was 552024T Fabric Engine. And when I looked back in the output for the unicast fib, I've corrected this now, but previously the output was showing the wrong information. Here we go. So you can see the host name was incorrect here. It should have been FEC. So when I did the layer 2 trace route, I was also using the wrong system ID as well. So there was two problems actually. So we just scroll all the way down to the bottom. I've corrected the system name, the host name, and as you can see here, I was able to do a layer 2 trace route. If I picked the correct system ID here, it did a layer 2 trace route from B to C, and I also did a layer 2 ping command to FEC, which now works. So I got a response with 0 packet loss. So let's move on and finish off the previous lab actually, because I hadn't done the IP shortcuts section C. So we'll just carry on and do that now. So here's the topology again, and we're going to create IP shortcuts in the global routing table, and this involves creating a clip management address, and the guide wants you to do it on A, B and C and not do it on D. So we'll proceed with the lab and see what that looks like. So FEC has been pre-configured with IP shortcuts and a management clip, so that may or may not be the case in my setup. So I'll start with A and finish C or complete C later if it's not got the management clip. So starting with A, just log into A. It's already logged in. And we're going to go to management clip, and we're going to assign an IP address 10.1.0.101/32, and we're going to enable it, and we're going to exit. On B, you'll have to log in to B, enable conf T, go into the management clip, assign an IP address of 10.1.0.102.32, enable and exit. For both A and B, log in and enter the global configuration mode, then the ISIS router. This one command enables IP shortcuts, so we have to go into router ISIS, and we have to enable IP shortcuts with the following command: spbm1 IP enable, and we do that on A, router ISIS, spbm1 IP enable. Okay, so what we can do here is do show ISIS spbm command, and you'll see at the top here under IP column it's enabled here, which means that IP shortcuts are enabled. And IP shortcuts allow you to handle layer 3 routes inside the fabric, and the nodes will share routes, ISIS routes with one another. So that's what IP shortcuts are used for. The clip address is actually recommended to use when you've got a VOS switch that's acting as a layer 3 switch. So if you create any VLANs with IP interfaces and have lots of those, it would be recommended to have a clip as your management rather than a VLAN as the management. So that's the recommendation. Just going back to the instructions. So for A and B, you must redistribute the local IP subnets to other nodes. So how do we do that? We do, let's exit out of here and do the, stay in router ISIS and do redistribute command. Redistribute direct. Routes will not be injected until you apply this command afterwards, so we have to do that at the very end. So we also need to do redistribute direct. Give it a metric of 1 and we have to enable it. Redistribute direct enable and exit, and then we have to apply, as the warning implied, ISIS apply redistribute direct, exit and save. Okay, and then we'll go to B and do the same on B. Stay in ISIS and do redistribute direct. Because the clip address is actually a direct interface, we need to redistribute it. So we redistribute direct and give it a metric of 1, and we redistribute direct enable, exit, ISIS apply redistribute direct, exit, save config. Okay, so verify IP shortcuts. So when we go to A and we do show IP route, we can see the global routing table, and we can see the ISIS routes that have been advertised from other switches. We can see 10102 as an ISIS route in the routing table, learnt from FEB, and also 1010102 is learnt from FEB as an ISIS route. Let's do the show IP ISIS redistribute command, and we can see we've got one statement there showing in the table that we're doing redistribution of internal networks, and this is enabled. Verify that the IP shortcuts are enabled, so we've already done that with the show ISIS SPBM command. We're going to look at the TLVs, the type, length, value options for the link state database. So we do show ISIS link state database TLV 135, which are IP shortcuts, and we can see some information here on that type of TLV. And if we want some more detail, just up arrow, put detail on the end, and we get more detailed information about those routes that we're learning over the Fabric, those IP shortcuts. So then it's saying examine the network management table, so we can do this command show auto topology space NNM table, and this shows our topology and neighbors that are connected to the switch and their MAC addresses, and which ports they're seen on, and the remote ports that they have. So that's a useful command. So that's just completing the previous lab that we had in the last video. So that's finished. We're just going to go down to lab 4 now, where it wants us to configure layer 2 VSNs again. So essentially we're going to configure a layer 2 VSN utilizing CU and I ports, and we're going to examine and verify their configuration. So again, we're using this right hand side here between C and D, but this time we're using VLAN 50 with an ISID of 2050, and so scroll down, looking at FEC's layer 2 VSN configuration. So we click on C. Well, let's look at our VLAN members. We don't have VLAN 50 at the moment. Show ports, VLANs, and VLAN 50 has already been created, it says, but it isn't, so I will create it with the VLAN create command. VLAN create 50 name. I presume it wants a name of 50 data, and we're going to give type port MSTP RSTP instance 0, and VLAN ISID will be the next command. So we bind the VLAN 50 with the ISID 2050, and we give the ISID a name, ISID name 2050, and we're going to call it 50 data. Make sure that on C that port 15 is a static member of 50 and that autosense is disabled, so we can check that autosense is disabled. Autosense, just specify the one port with 15. So autosense is disabled, and if it wasn't, we'd go in to interface 15 and disable it, but we need to check the status of the port 15 just to see if it's shut down. It isn't, it's administratively enabled, so we don't need to do the shutdown, and we need to add, I think we need to add the VLAN to the port, so show VLAN members. So yes, we haven't added 15 to 50, so we'll do that now. VLAN members add 50 to 15, and then verify that that is moved, which it has. And so we've done all of that, and we're just going to save the config. And it wants us to do on D the same thing for this layer 2 VSN. So RWA enable conf T, So we're going to do VLAN create 50, give it a name, 50 data, type, port, tab, 0, VLAN ISID 50, 2050 return, auto sense data ISID 2050. A name will be assigned to the auto sense ISID 50. Okay, well, let's type that command: auto sense data ISID 2050. Oh, spelling mistake. Let's put that T in there. And okay, note in the virtual environment, auto sensors limitations. Blah, blah, blah. Configure C port 15 as a member of VLAN 50. I think I did that. And verify that. Okay, so I think we're actually on D. So we just need to check that what the VLAN membership is like on here. So we need to add VLAN 50 to 15. VLAN member add 50 to 15 and confirm show VLAN members that 15 is now in 50. I'll just confirm the ISID is present whilst we're here, which it is, and that's completed that bit. Verifying, so on the PCC it wants us to put in the following IP addresses, so let's go to C, we just show IP, and we're just going to change it from, change its IP address to be 10.150.71 with a /24, and the gateway is going to be 10.1.50.3. Okay, the gateway has been pre-configured. Okay, in on VRF purple. Well, we haven't actually done that, but we'll go to PCD and make sure the PC's got the correct IP address. So show IP, just see what it is. I need to change to IP 10.1.50.81/24 with a gateway of 10.1.50.3. Okay, so I haven't put it in a VRF, but we can just prove we can ping across the fabric. And I haven't put the IP address on the VLAN either, but let me just see if I can ping across to 10.1.50.71, which I can. So the layer 2 VSN is working. Yeah, so here's some summary of the VLAN, the Lab 4 configuration on C and D, and that concludes the Lab 4.